Hi again. In the first tape of this series, you've learned what humidity is and who needs it. And we traveled around a bit to see why it's important. In this tape, we're going to concentrate on how to humidify. But that's hard to do here where it's so noisy and so hot and so humid. So let's travel once more back to the studio where it's more comfortable. That's better. Now, obviously, there's a great difference in the design criteria for a humidification system in the lumber curing room of a furniture factory and one in a computer facility. These different requirements determine which method of humidification should be used. There are 4 basic methods. The simplest is the wetted element humidifier. A hygroscopic element is partially submerged in water. As dry air is forced over the upper part of the element, water is wicked from the saturated portion and evaporated into the airstream. A related design is the evaporative pan method. Again, a pan is partially filled with water and the dry air current is forced over the top. Evaporation is assisted, however, by heating coils placed in the pan. These coils may use steam, hot water, or electricity to raise the temperature of the water, causing it to evaporate more readily. Another approach is the water spray method. These humidifiers mix pressurized water with compressed air through a nozzle. This atomizes the mixture directly into the airstream. The 4th approach is the steam method. Here, live steam is passed through a separator to remove condensate. The conditioned steam then passes through a metering valve and a drying chamber before being discharged. By examining the major factors important to effective humidification, we can compare the 4 approaches and determine their suitability to any particular application. The heat of vaporization reduces sensible heat in the air by about 1,000 BTUs for every pound of water that is evaporated. In both the wetted element and water spray method, that heat is supplied by the surrounding airstream, lowering the air temperature of the system. The evaporative pan method provides most of its own heat of vaporization, therefore raising the enthalpy and slightly affecting the air temperature. The steam method uses water that is already vaporized, so it has no effect on the air temperature. The capacity of a humidifier is the maximum amount of moisture it releases over a period of time. Small capacity units are best applied to small spaces or environments where little change is called for. Greater capacities are called for in larger spaces or when the humidity must be raised significantly. Wetted element humidifiers have the lowest capacity, suited mostly to private dwellings or similar very low capacity applications. Where medium capacities are called for, either a steam humidifier with a self-contained steam generator or an evaporative pan humidifier provide the best economics. Large capacity applications require either the water spray or the steam method. In any case, the humidifier may be installed either in an air handling system or individually within an area for non-ducted applications. Maintenance is an ever-present concern. Humidifier care for all 3 liquid-based methods is completely dependent upon the mineral content of the supply water. Removal of mineral deposits must be scheduled for the pan, hygroscopic elements, and heating coils of the 2 stationary water methods, and from the nozzles and surrounding ductwork of water spray humidifiers. Because of the waterside care that is essential to efficient steam system operation, steam humidifiers require minimum maintenance. Humidifiers are operated by controllers which are placed either in a space that is to be humidified or in the return air duct. A humidifier's response to control is gauged by the time it takes the unit to satisfy humidity demands. The key here is the state of the water when the humidifier is at idle. The wetted element method supplies water as required by level setting switches in the pan. Evaporation, however, is totally controlled by the passing airstream and therefore dependent on heating requirements. Evaporative pan humidifiers turn on when commanded, but the water still must be vaporized in order to humidify the air. The steam and water spray methods have immediate response. The output of the steam units is already vaporized, and the water spray medium is atomized, which immediately mixes with the air. Once the humidifier has been turned on, it must track the required changes. Its ability to do so is dependent on how its output is controlled. Wetted element and evaporative pan humidifiers can only be turned on and off. Their output is therefore controlled by predetermining the sizing of the water surface, the exposed element area, or the heating coil temperature. The steam and water spray units, however, can have valves that can be opened, closed, or modulated to any intermediate position. Sanitation is a major consideration. Of the four methods, only steam provides a sterile humidification medium if the waterside care and the installation are proper. Evaporative element and water spray methods distribute any waterborne bacteria in the supply water throughout the humidified environment. Additionally, wherever water precipitates out of the airstream and collects, there is a potential for algae and bacterial growth. Bacterial distribution from an evaporative pan system is dependent on water temperatures and treatment, as well as cleaning. Corrosion is likely in a humidification system whenever water is present as a liquid. Since the steam, evaporative pan, and wetted element methods discharge water vapor, the ductwork in a properly designed system should be free from corrosion. The reservoirs of the two standing liquid-based systems may have corrosion problems related to water quality. Every component of a water spray humidifier is susceptible to corrosion problems. The cost of humidification is our final consideration, the so-called bottom line. It is also one of the most complex, having several elements that must be looked at. The operating costs of any of these methods, if properly designed and installed, is low when compared to the accompanying comfort control system. The installation costs are dependent upon the availability of steam, hot water, electricity, compressed air, and makeup water at the humidification site. Initial costs vary with the size of the units and therefore must be evaluated according to individual capacity requirements. Based on capacity alone, however, steam humidifiers have the lowest cost per unit of output, followed by water spray, evaporative pan, and wetted element systems. Added to the purchase, installation, and operating expenses are the maintenance costs. As we've said, maintenance on a steam humidifier is negligible, about once a year. Depending on the feed water quality, evaporative pan systems should be inspected or cleaned weekly to monthly. Water spray and wetted element humidifiers may also require weekly cleaning, but need attention at least once a month. When we compile the results, the application range of each method becomes obvious. Ultra-low capacity wetted element systems have no application outside of private dwellings or similar small spaces where the humidification load is very small. The evaporative pan method is suited to commercial and industrial applications with loads under 75 pounds per hour, where sanitation, low maintenance frequency, or precise control are not required. Water spray humidification is the best choice for industrial environments where evaporative cooling is also desired. A typical application is summertime humidification in southern U.S. textile mills. The steam method is recommended in virtually every commercial, industrial, or institutional application by virtue of its controllability, low maintenance, sanitation, and resistance to corrosion. Additionally, apart from the lower overall final costs of steam humidification, there are further savings in the many locations where there is an existent boiler supplying comfort control or process steam. In low-capacity applications that don't meet the criteria for the evaporative pan method, the steam method is the best choice using a humidifier with a built-in self-contained steam generator. Quite obviously, steam humidification has the widest application range of all the methods we've addressed. It is from both the medium and the design that steam humidifiers gain their versatility. The steam humidifier was invented by Adam Armstrong in the early 1930s. It was the product of both fascination and necessity. The former was the result of insight Adam had gained into the advantages of steam since his company, Armstrong Machine Works, introduced the IB steam trap in 1911. The latter was the result of an annoying skin disorder that plagued Adam's life. Although the product has been developed and refined through the years, the principles and advantages of the 9000 series steam humidifier from AMW have changed little since the beginning. It all starts with steam. The steam is applied to the humidifier through an Armstrong strainer. This inline Y strainer uses a retainer bushing that is gasketed and has non-tapered threads for easy service. The crush-proof screen removes all particles from the steam that are more than 45 thousandths of an inch. Next, the supply steam is routed through a jacket in the manifold that surrounds the distribution pipe. This eliminates condensation in the distribution pipe due to radiation losses. From here, the steam enters the one-piece cast iron body that forms the separator and drying chamber. The thick cast iron walls provide pressure flexibility, dampen noise and vibration, and provide excellent heat retention, minimizing radiation losses from the humidifier. The one-piece body construction eliminates the possibility of leaks at joints. The separator is a labyrinth that reverses the supply steam direction twice, reducing its velocity and causing the condensate to precipitate out. The condensate removed by the separator or created by radiation losses drains from the bottom of the humidifier into a large drain leg. Most of the particulates the strainer didn't remove from the supply steam also settle out into the drain leg because of the reduced steam velocity through the separator. Condensate is evacuated from the drain leg through an Armstrong cast iron inverted bucket steam trap. This trap was chosen for several reasons. An IB trap can handle a wide range of pressures, so resizing isn't necessary if steam requirements change. The IB trap has only two moving parts with no fixed pivots or complicated linkage. Its simplicity provides for a long service life compared to other trap types. If eventually the trap does need service, the entire operating mechanism is removed with the cap. The trap body never has to be removed from the line for maintenance. Another important advantage is that IB traps almost always fail open. This may reduce efficiency, but will not flood the humidifier or its surroundings. After the condensate is removed, the conditioned steam is channeled to the top of the unit where it jackets the metering valve. The metering valves are made by Armstrong and installed as an integral part of the humidifier. Whether the valve operator is pneumatic, electric, hydraulic, or electronic, the same modulating characteristics, wide rangeability and interchangeability, can be maintained for any orifice size. Additionally, if you need to change the operator of an existing unit for any reason, you can field retrofit the appropriate valve stem and seat assembly and never touch any plumbing. After passing through the metering valve, the steam enters a drying chamber that is also jacketed by steam from the separator. Any mist remaining in the steam is re-evaporated here before distribution. This allows the 9000 to be used for either duct or area distribution without concern about spitting. The drying chamber is filled with a stainless steel drying material, which also serves as a silencer or muffler for the escaping steam. The short path from the humidifier to the jacketed distribution manifold, like so many other features of the Series 9000, was chosen to minimize radiation losses and condensation. Inside the Schedule 5 distribution pipe is a stainless steel mesh screen that runs its full length to prevent whistling as the steam flows past the outlet holes in the distribution pipe. For large capacity operations, the Series 9000 humidifier is a versatile, wide-ranged humidifier with a long history of dependable performance. All applications, however, don't require the capacity of the 9000. Additionally, most of these smaller applications have no boiler to supply such a unit. Where the benefits of a steam humidifier are required to meet small capacity applications, the best choice is a steam humidifier that has a self-contained steam generator. The Armstrong EHU series of humidifiers offers a broad range of such products, complete with accessories to meet any application. Although these units approach humidification a bit differently than the Series 9000, they also use steam and are designed and manufactured by Armstrong, the people with the most experience in steam humidification in the world. EHU humidifiers are self-contained units which use untreated tap water to produce steam. The heart of the system is a cleanable plastic electrode-type steam generator. Suspended inside the generator tank are stainless steel electrodes. When water reaches the electrodes, it conducts electricity between them. This heats the water, generating steam. As the water level rises, there is more contact with the electrodes and therefore greater current flow. As the current flow increases, so does the heat, creating more steam. The unit is supplied with a humidistat that uses a lithium chloride crystal pre-selected for a specific relative humidity range. When the RH at the humidistat falls below the set point, it generates a voltage that is proportional to that humidity difference. This signal is sent to an electronic controller which opens a fill valve, allowing water to enter the tank. When the water contacts the electrodes, current flow starts and is sensed by the controller. The fill valve is held open until the current flow in the tank reaches the level necessary to produce enough steam to satisfy the humidification requirements at the humidistat. The steam that is generated may be dispersed through a distribution manifold in an air handling system or to an attached fan package for area distribution. There are several additional operational sensors routed to the Armstrong electronic controller, as well as optional inputs for convenience accessories. A high water probe is provided in the tank to prevent overfilling. The automatic drain system opens a valve at the bottom of the tank, which discharges water intermittently to prevent mineral buildup. Other accessories available are a duct high limit stat that cuts back humidity production once a preset limit has been reached, and a sail or pressure switch that can be placed in a duct to stop steam generation if airflow fails while humidification is being called for. Well, that about does it for this series. In this tape, we've looked at the 4 common methods of humidification and compared their responses to several common factors that must be considered in evaluating a system for a specific application. We've also looked more closely at steam humidifiers because that medium is the most widely applicable. If you haven't seen the first tape in this series, I suggest that you do so, especially if you've decided that you don't need to be concerned with humidity. It explains humidity, relative humidity, and discusses the scientific principles involved in understanding the subject. It also presents the thoughts of several experts as to how important humidity is to their work and to your life. Armstrong Machine Works has also compiled a handbook on humidification and released several bulletins on its importance to various industries. Contact your Armstrong representative. He can get you any of these materials on humidity and humidification, as well as provide you with expert knowledge about steam and its many applications.